Hello, my name is Dane Powell, and this is my schematic design proposal for Ocean Academy, located at 375 Harrison Avenue in Boston South End. From a code standpoint, the building is developed as a 5-story, fully sprinklered E-group educational building of type 2A, protected non-combustible construction, with a steel column and beam structural system, 2 exit stairs, and a 2-hour rated core with 2 elevators for accessibility. The project serves the middle school age range, but is organized not by fixed grade levels, but by 4 developmental learning clusters: emergent, formative, applied, and advanced. The project is responding to a very urban site. Harrison Avenue is the busier commercial edge, while Washington Street provides a calmer pedestrian and transit approach. The condition shaped both the building form and the access strategy. The building arcs around the edge of the lot to create a protective urban barrier along the more intense side of the block, while opening toward the safer and calmer side of the block, which is Washington Street. The step mass then moves down Washington Street, where the context is more residential with single-story buildings. The form is doing several things at once. It gives the school an urban presence along Harrison, but also shelters the learning environment within, creates an interior courtyard, and sets up a west-oriented access condition for students, staff, and family. This page shows the massing logic by floor. The design begins with an arcing footprint. From there, the building steps upward, reducing bulk and creating opportunities for terraces and unique educational spaces. Pedagogical idea is the most important driver of this design. Ocean Academy is grounded in a constructivist model where students learn through inquiry, making, testing, and reflection. Because of that, the building was not organized as a double-loaded corridor with a row of classrooms. The second and third floors are built around open learning clusters, commons, quiet rooms, maker studios, and flexible study pods. Rather than assigning students to a traditional grade-based zones, the school is organized into emergent, formative, applied, and advanced clusters. These academic clusters are enhanced by a variety of maker and media labs found on the 4th and 5th floors. This keeps study and concentration areas separate from noise-making projects. This board shows how the lower levels share the civic and shared functions, including entry, administration, commons, gym, and cafeteria, and auditorium pit. As the building rises in floors, it becomes more focused on learning environments, learning clusters, making labs, library spaces, quiet pods, and roof gardens. As you move up from the learning clusters, the upper floors have the maker labs, and the library and media center. Boston's climate is cold, humid, and highly seasonal, so heating performance and envelope design are going to be major priorities. However, summer heat, humidity, and required shading, ventilation, and dehumidification are something you must consider as well. First, the curved geometry on the site helps distribute the solar access through every day across multiple faces of the building, which is important in this urban context with all the surrounding shadows. The step profile creates terraces and rooftop gardens that extend the learning environment outdoors while also helping with heat gain and ecological programming. Mechanically, the project is conceived as a cold climate VRF system with a DOAS for fresh air, and the project will also include a solar array to supplement the building's electrical loads. This board shows the structural logic of the building. The building was conceived as a steel column and beam system, but because the plan is curved, the structural order is based on a polar array rather than a standard grid. I didn't want the curve form to feel arbitrary. The structure works with the architectural logic, not as an afterthought. It supports longer spans, greater flexibility, and a more open floor plan, which is the way I want to go with flexibility, which are all important to my cluster-based learning model. Circulation in this building is very simple. There are really no corridors. Every floor is really an open modular approach, so that but there is a central core, a vertical core with 2 elevators and stairs. Note that this model does not include the second egress staircase that I realized was required by code, and that's been added in later iterations. The massing view shows the project's overall connection to the city. The building has both an urban edge off of Harrison Street and a protected inner landscape that is on the Washington Street side. It creates a strong street presence, but encloses the calmer, more focused student environment inside the block. The stepped arc is visible in all these views, and as the building it creates a feeling that's more responsive to the context of the neighborhood and certainly is more aligned with my educational ideas. To conclude, this project proposes a school that is the response to site, climate, pedagogy, and student development, all integrated into one architectural idea. The curved step form addresses the urban block, protects the inner landscape, and supports daylight, terraces, and environmental performance. Inside that form, the school is organized not by fixed grade levels, but by developmental learning clusters, emergent, formative, applied, and advanced, instead of grades 5 through 8. That framework better reflects how students grow and how a flexible educational environment can support them. Thank you.